Good day. I am Jeric B. Martinez from 4th year Bachelor of Science degree in Civil Engineering, Section A. Today I will be explaining about my assignment Response Spectrum Analysis for 10-story building. This analysis is based on NSCP 2015 and we assume that the columns are massless and the infill walls are not present. So CA, we assume CA is equal to 0.44, CV is equal to 0.64. So let's proceed with the step 1. Mass matrix and stiffness matrix. So using the given mass and stiffness of the 10-story building, we will be able to generate our mass matrix and our stiffness matrix. So given for mass, for first floor to ninth floor, in each floor, we have 1.429 ton of mass. And for the 10th floor, we have 1.089 ton. So with this given value of the mass, we can generate our mass matrix. So this is our mass matrix. So this is our mass matrix. The mass are plugged in diagonally. So this will be used in solving the next steps. Stiffness. So with this given value, we can be able to generate our stiffness matrix. So the stiffness of first floor is 3,727 million Newton per meter. And the stiffness of second to ninth floor, so in each floor we have 1,779 million Newton per meter. For the 10th floor, the stiffness is equals to 1,511 million Newton per meter. So this will be our stiffness matrix. So saan ang galing itong 5,506? This value comes from the uh, sum of the first floor stiffness and the second floor stiffness. We can solve these values, this 5,506, 3,558, to 3,290 and 1,511 by using that formula. So ito yon. Stiffness plus Stiffness 2 is equals to 5,506. Stiffness 2 plus stiffness 3 is equal to 3,558. Stiffness 3 plus stiffness 4. Stiffness 5 plus stiffness 4 plus stiffness 5. Stiffness 5 plus stiffness 6. Stiffness 6 plus stiffness 7. Stiffness 7 plus stiffness 8. Stiffness 8 plus stiffness 9. And stiffness 9 plus stiffness 10. And for the stiffness 10, we have this value. So, ito na yung magiging ito na yung magiging stiffness matrix natin, no? Let's proceed with the step 2. Solving the eigenvalues, frequency, and period. Using this characteristic equation, plug in into a matrix, we can be able to solve for the eigenvalue. So, ito yun siya. Determinants. So, solve natin yung determinant nito. Makukuha natin yung value ng lambda or yung eigenvalue. So, ito yun. Ito yung k natin. K, lambda, minus lambda. Then, ito yung m. Mapapansin nyo, 1,429 siya. It is because we converted the 1.429 ton and the ito step 2, solving the eigenvalues, frequency, and the period. So, using this characteristic equation, plug in into a matrix, we can be able to solve for the eigenvalue. So, ito yun siya. Determinant. 5,506. Ito yung K natin. 5,506 million. Ito yung K. Minus lambda. Ito yung hahanapin natin. Ito yung eigenvalue natin. Then, for mass, we have 1,429. Tataka kayo kung bakit naging 1,429 yan. It is because we converted the 1.429 ton into a kilogram. So, it will become, or it will be multiplied by 1,000. Then, the result is 1,429 kilogram. So, the rest, the same process. Ito. Ayan. So, ito yung 10th floor natin, no? 1,551, ito yung stiffness, minus the lambda, times the mass, which is 1,089. If we solve this determinant, we can be able to find our eigenvalue. Ito yun. Itong eigenvalue natin for mode 1, 32, for mode 2, 284, and so on. For mode 10, 4,976. Ito yung value na ito, gagamitin natin ito to find the frequency in the period. So, ito, meron tayong eigenvalue. Masolve natin itong frequency. Bakit? Kasi itong frequency is equal to the square root of the lambda, o the square root of the 32, square root of 284, square root of 755 for mode 3, and square root of 4,976 for mode 10. So, yung sa period naman, t is equal to 2 pi over the frequency. So, magiging 2 pi over the square root of lambda. So, magagamit natin itong formula nito para mahanap natin itong frequency at saka period. So, ito yung magiging result. For mode 1, for frequency, we have 5.65685. For mode 2, 16.8523. So, ulit, frequency, nakuha natin to pag in-square root natin ito. Square root of 32, ito. Square root of 284, ito. Square root of 755, ito. And so on. Yan. Frequency naman, sa period naman, ito. 2 pi over the frequency, which is 5.65685 for mode 1. So, ito yung result, 1.11072. 2 pi over this frequency, and result, 0.37284, and so on. Ayan. So, itong mga value na ito, kakailanganin natin ito for the following steps. So, let's proceed to step 3. Step 3, calculate the eigenvector for each eigenvalue. So, using the eigenvalue na na-generate natin kanina, we can be able to solve for our eigenvectors. So, for mode 1, we have this lambda, which is our eigenvalue, equals to 32. So, ito yung matrix natin ng characters na kung saan naka-plug in yung characteristic equation natin. So, dito, naka-plug in yan dito. Ito yung 5,560 minus lambda times 1,429 kanina. So, isa-substitute lang natin itong lambda doon sa sa equation na mga yan. Then, makukuha natin itong mga value na ito. Ito, mga value na ito, at saka ito. Ayan. Step 3, calculate the eigenvectors for each eigenvalues. So, using the eigenvalues na generate natin kanina, na determine natin kanina, masosolve natin ngayon yung eigenvectors. So, punta natin sa proceed tayo sa mode 1. For lambda is equals to 32, or the eigenvalue is equals to 32. So, ito yung matrix natin wherein characteristic equation was plugged in. So, nandito kanina yung 5,560 minus lambda times 1,429 na equation natin. So, ipa-plug in lang natin yung lambda 32 natin dito. Then, ito yung magiging result niya. The same dito, hanggang sa abot tayo ng mode 10 sa 10th floor. So, ito. Pag na-solve na natin yon, ito na yung magiging matrix natin kung saan nandito rin yung characteristic equation natin. So, paano natin ito isa-solve? Ayan. So, ito yung hanapin natin. Multiply natin siya sa eigenvector 1, until eigenvector 10. So, paano yan? Ano yung magiging, niyan? Ano yung magiging value nito? Since wala pa tayong value, transpose natin ito sa kabila. Itong green na part. Ayan. So, negative will become positive. Then, itong nung naka-color red na ito, i-convert natin yan into, or we will assume that the eigenvector 10 is equals to 1. So, kung meron tayong value dito na isa, we can be able to solve for the rest of the eigenvectors. So, multiply lang natin itong 9 equation, 9 unknown, or 9 by 9 matrix natin. Multiply natin itong 9 by 9 matrix, inverse ng 9 by 9 matrix na ito, dito. Pag na-multiply natin dito, makukuha na natin yung eigenvector natin from 9 to 1 down to 1. So, ito yung result niya. Ayan. So, ito yung in-assume natin. Ito, na eigenvector 10, which is equals to 1. Then, the rest, na-solve na natin gamit tong process na yan. Yung multiplying this inverse of this 9 by 9 matrix to this vector. So, ito yung result. Kung ipa-plug in natin yan dun sa graph natin, ito yung magiging graph natin. Ito yung mode shape natin. Ayan. Kung makikita nyo maraming points, hindi na siya line. Medyo curved na siya, no? So, ito yung magiging mode shape ng mode 1 natin. So, for mode 2, the same process. Ito yung characteristic equation matrix natin. Nandito yung characteristic equation. Pa-plug in natin yung value ng lambda, which is equals to 284 dito. Dito, hanggang makabot tayo sa mode 10, 10th floor. So, the same with the mode 1 na sinolve, ganyan. So, lilipat natin ito dito, negative becomes positive. Then, inverse of this 9 by 9 matrix in color pink or peach, kung multiply natin dito, so, makukuha natin yung mga eigenvector natin, 10 eigenvector. We assume that the eigenvector on 10th floor is equals to 1. So, ito yung magiging eigenvector natin. So, pa-plug in natin yan dun sa mode shape. Yung mode shape graph natin, ito yung magiging graph. This will be the mode shape for the mode 2. Ayan. So, mode 3, the same. Ayan. Ito yung eigenvector. Ito yung mode shape. Ito yung eigenvector. Ito yung mode shape natin. So, ayan. Ito ipa-plug in lang natin itong lambda dito, no? Yan lang gagawin natin until marating natin yung mode 10 sa lahat ng pag-solve natin lahat yung mode 1 to mode 10, ganun yung process natin, no? Ito yung characteristic equation nandito. Plug in natin itong lambda na 755 dito. Dito, kung ano man yung value ng lambda na nasa mode, kung saan tayo nagsosolve na mode, dito, hanggang sa mode 10th floor. So, ayan. We assume that this eigenvector 10 is equals to 1, then we can be able to solve for the rest of the eigenvectors. So, ito na yun. Ayan. Ito na yung mode shape natin, no? For mode 3. For mode 4, the same process. Ayan. Ayan. Mode 5, ganun din. The same process. We plug in this, this value of lambda, 2133 to this characteristic equation matrix natin. Then, this 9 by 9 matrix will be multiplied to this vector. Then, you can be able to solve for our eigenvectors. So, plug in natin yan dun sa, sa graph. Makuha natin yung mode shape ng mode 5. The same with 6. Mode 6. Ayan. Ganun din. Pag nakuha natin yung eigenvector, plug in natin sa mode graph natin. Makuha natin yung mode shape. Mode shape ng mode 6. Ayan. Lambda natin sa mode 7 is equals to 3601. Plug in natin sa matrix natin. Then, ayan. So, pag nakuha natin yung eigenvector, ilagay na natin siya dun sa i-graph na natin siya. Then, makuha natin yung mode shape natin. Mode 8, the same. Ayan, ito yung, ito yung tsura ng mode shape natin sa mode 8. Next, mode 9. The same process. Meron tayong 10 eigenvector. We assume that this eigenvector 10 is equals to 1. Then, plug in natin itong value dito sa, graph. So, ito yung magiging mode shape natin. The same with the mode 10. The lambda is equals to 4976. So, characteristic equation dito. I-plug in natin yung value natin. Then, transpose or lipat natin ito sa kabila. Negative becomes positive. Then, this value, 9 by 9 matrix, inverse of this 9 by 9 matrix will be multiplied to this vector. Then, our eigenvector will be this one. Ito. Ayan, 10 eigenvector. We assume that the eigenvector 10 or the phi 10 is equals to 1. Then the mode shape, ito na yan. So if you combine those mode shape from mode 1 to mode 10, ito yung magiging result natin, no? Combining all the mode shape. So ito yung magiging itsura ng mode shapes natin. So let's proceed. Participation of modes. Participation of modes. So we will be solving two unknowns here, the modal participation factor and the modal participation percentage. Modal participation factor represented by the uppercase gamma n, and the modal participation percentage represented by PM n. So, step 4, compute the modal participation factor. So, using the formula, gamma equals to L over m hat, or the gamma is equals to m hat negative 1 raised to negative 1 times L, or gamma is equals to inverse of generalized mass matrix times coefficient vector L. So, ito yung generalized mass matrix, inverse generalized mass matrix, and itong L is the coefficient vector. So, for L, we will be using the equation or the formula. L is equals to phi transpose mass times D. For M hat naman, or for generalized mass matrix, so M hat is equals to phi transpose, or the eigenvector transpose, times the mass matrix times the eigenvector na hindi transpose. So, kailangan natin ng mga values nito. So, ano yung mga value nito? Ito yon. Ito yung para sa eigenvector na hindi transpose. Ito naman yung para sa transpose. And ito yung para sa D. Itong D is the directional displacement vector. So, we put this values 1, 1, 1, 1, 1, 1. So, 1 because we want to consider all of the modal participation factors. So, kailangan gusto natin i-consider lahat. So, kailangan 1. Kung meron tayong hindi consider, pwede natin lagyan ng 0. Pero, dito, kailangan natin i-consider lahat, no? Para sa, solving natin. So, para naman dun sa, sa M, or sa mass matrix natin, ito yon yung kanina. Then, coefficient vector, ito na. So, plugging in the values of the transposed eigenvector times the mass matrix times the directional displacement. So, ito na yung magiging result natin. 10 by 1 vector. Bakit 10 by 1? Kasi, ang first natin na isosolve is itong eigenvector na transpose times the mass matrix. So, 10 by 10 matrix times 10 by 10 matrix is equals to 10 by 10 matrix times the 10 by 1 vector, which is our directional displacement vector. So, magiging result nun, 10 by 10 by 10 by 1 is equals to 10 by 1 vector. So, ito yung magiging coefficient vector natin. Igagamitin natin dun sa formula kanina. So, solving for generalized mass matrix. So, pag na-solve natin ito, pag nakuha na natin ito, transpose na phi times the mass matrix. So, 10 by 10 matrix times 10 by 10 matrix is equals to a 10 by 10 matrix times yung hindi transpose na eigenvector. So, 10 by 10 din ito. So, 10 by 10 times 10 by 10 matrix is equals to 10 by 10 matrix. Pag na-solve na natin yun, hindi natin pwedeng sabay na isolve itong tatlo, no? Dapat ito muna. Then, yung result nito, i-multiply natin dito. Then, pagkatapos nun, i-inverse natin. So, inverse generalized mass matrix. So, ito yung gagamitin natin. Ipa-plug in natin ito dun sa value kanina. So, ano yung result nito? Ito yon. Ayan. Ito na yung didiretso ko na, inverse generalized mass matrix. So, ito na yung magiging value natin para dun sa formula kanina. So, since we already have data needed, we can now solve for the modal participation factor. So, ito na. I-plug in natin itong value na ito, itong 10 by 10 inverse generalized mass matrix dito. Then, i-plug in din natin itong coefficient vector L, 10 by 1 vector dito. So, magiging result niyan is a 10 by 1 vector. Ayan, modal participation factor. Modal participation factor, or gamma, is equals to the m hat inverse times the coefficient vector L is equals to, eto na, so 1.27 for the mode 1, mode 2, mode 3, mode 4 to mode 10. Therefore, our modal participation factors for all modes. So, ito na yon. Ito yung mga value natin, no? Gamma 1 is 1.279894, gamma 2, negative 0.43635, and so on for gamma 10, negative 0.01173. So, ayan. Next, step 5, no? compute the modal mass participation percentage. So, paano natin ito i-compute? So, ito yung PM kanina, no? PMN is equals to M effective modal mass over the total mass times 100%. So, ito yun. Yan. Ito yung magiging equation natin or yung formula natin. So, given effective modal mass. So, ito yung solve natin yung effective modal mass, no? Hindi ito given. Solve natin ito gamit itong coefficient vector L times the gamma. No, yung modal participation factor natin. So kapag i-multiply natin ito, so ito yung coefficient vector natin, 10 by 1 vector, tapos ito yung modal participation factor natin, 10 by 1 vector. So multiply natin yan gamit ang Hadamard product. Paano ito ang Hadamard product, no? I-multiply lang natin itong magka-level, no? 8.82798225 times 1.279894449 is equals to 11.29888858. So, for number 2, or for mode 2, negative 2.933733722 times negative 0.43634637 is equals to 1.280125559. So, ayan. So, ito yung mga result natin and so on, no? I-multiply natin yan hanggang makabot tayo sa mode 10, no? So, ito yung result. So, ito na yung effective modal mass na gagamitin natin, na ipa-plug in natin dito sa equation. So, paano naman yung sa total? Ito, ito-total lang natin ito. Sum up natin ito. Then, ito na yung total natin. Then, itong effective modal mass divided by the M total times the 100% is equals to the modal mass participation percentage. So, ayan. Ito yung result niya. Modal mass participation percentage. So, PM is equals to MEFF over M total times 100% is equals to, so ito yung magiging result niya pag i-plug in natin dito yung mga value. 80.9956, 9.176528, 3.382792, and so on. Therefore, the modal mass participation percentage for all modes, ito. So, mode 1, or the modal mass participation percentage 1, represented by the PM, mode 1, 80.9956, for PM2, 9.176528, and so on. Pag i-solve natin ito, or ang value nito, sum nito, total, 100%. So, naka-percent pala ito, no? Naka-percent. So, total niya, 100%. So, sabi sa NSCP, okay na yung 90%. Pwede na natin yung, hindi na yung gamitin natin, no? So, kung 90%, hanggang mode 2 lang tayo, no? Hanggang mode 2 tayo, hanggang second floor, 9.176528 plus 80.9956. Almost, sobra 90 na ito, no? Sobra 90% na ito, 90 point something na ito. So, pero dito, kailangan gusto natin i-consider lahat. Kaya nga, yung D natin kanina is 1 lahat, no? So, kasi gusto natin i-consider lahat. So, consider natin yung 100%. So, gagamitin natin lahat yan. Ayan. So, proceed na tayo. Spectrum curve. Ano yung susolve natin? Itong dalawa. SA, or the spectral acceleration, and the SD, or the spectral displacement. So, may mga corresponding solutions din to sila. So, step 6. Calculating the spectral acceleration based on the different modal periods using figure 208-3 of NSCP 2015. Ano itong figure 208-3 of NSCP 2015? Ito yon, yung figure na yon. So, hahanapin natin dito yung points, no? Saang points dito yung spectral acceleration natin, no? So, may mga formula din tayong gagamitin dito. Given that our period 1 ito, period 2 ito, may mga kasi tayo, may mga conditions tayo. So, assumptions natin kanina, CA is equals to 0.44 and CB is equals to 0.64. So, solve natin yung TS, no? TS is equals to CV over 2.5 CA. So, ilalagay lang natin itong value dito. Then, result is 0.582. Then, our 0.2 TS is equals to 0.2 times 0.582 is equals to 0.116. So, ito yung value natin sa TS. Ito yung value natin sa 0.2 TS. Bakit kailangan natin hanapin? Sabi ko kanina, gagamitin natin itong graph. Dito natin hanapin itong mga points kung saan dito yung spectral acceleration natin. So, yan. So, period natin, no? Period kanina, nakita na ano. Oh, ayan. Ito yung period natin, no? Yung periods. T1 is equals to 1.110721. So, T2, 0.3728838. So, T3, 0.2286869. So, bakit kailangan natin ito? So, kasi meron tayong conditions. Kung yung T1 daw natin is greater than TS, yung na-solve natin ng TS kanina, 0.582, from the ano ito, no? From the, doon sa figure, na-solve natin, with the assumed value of CA and CV. Sabi na kapag ang condition, ang T1 or yung period natin is mas mataas kaysa sa TS, then ito yung gagamitin natin na formula. SA is equals to CV over T. So, yan yung gagamitin natin na formula. Paano naman kapag 0. Yung T2 natin or yung period natin is larger than 0.16 but less than 0.582, ano yung magiging formula na gagamitin? So, ito, SA is equals to 2.5 CA. So, itong 1, 2, 3, 4, 5, period 2 to period 6, ang period dito is greater than 0.116 but less than 0.582. So, since ganun yung conditions niya, so since yun yung mga value dito, so ang gagamitin natin na formula for this periods, for these conditions, so is SA is equals to 2.5 CA. Paano naman kapag kapag less than 0.116, ano yung gagamitin natin na formula? Ito. So, dito sa period 7 natin to period 10, mga periods dito ay less than 0.116. So, kung less than 0.116 yung period natin, ang gagamitin natin na formula is ito. SA is equals to 18.75 CA squared over CV times TN. Ano itong TN? Ito yung T7, T8, T9, and T10 plus yung CA. So, kapag gagamitin natin ito na formula, magiging result yan. Yan. Ito yung spectral acceleration natin. SA is equals to CV over T. So, CV natin is 0.64 yun kanina, no? Ayan, 0.64. So, ayan, 0.64 over T. Ang T natin, 1.110721. So, ang result niya, 0.56202 G. Bakit may G? Wala namang, bakit may G? Gravity ito, no? Ito yung, since acceleration, meter per second squared. So, ito yung, ito yung gravity, no? So, i-multiply natin yung gravity dito sa value. So, our final SA, for SA1, for mode 1, or for period 1 is equals to 5.652546 meter per second squared. So, for for T2, 1.1 G. So, 1.1 times 9.81 meter per second squared. So, SA2 is equals to 10.791 meter per second squared. So, the same process sa 1, 2, 3, 4, 5. Sa limang ito, the same process, no? So, ganun din dito. So, SA is equal sa, sa T7 to T10. SA is equals to 18.75 CA squared over CV times TN plus CA. So, dito sa, T7 natin, mode 7. SA is equals to 18.75 times, yung CA? 0.44 squared over CV or 0.64 times TN or T7, 0.104705 plus yung CA na 0.64. So, ang result, 1.033875 G. So, final spectral acceleration natin for T7, for mode 7 is equals to 10.14231 meter per second squared. So, using this process, using this method, the same with the T8, T9, and T10. So, ito na yung mga magiging value natin. So, spectral acceleration 1 is equals to 5.65 meter per second squared. spectral acceleration 2 is equals to 10.79 meter per second squared. The same with spectral acceleration 3, 4, 5, 6 since they have the same values. So, next, dito naman tayo sa SA7, spectral acceleration 7, 1.033875 G is equals to 10.14231 meter per second squared. Spectral acceleration 8, 9.69. Spectral acceleration 9, may 9 ito, no? Yeah, may 9 ito. Hindi natanggal, no? Equals 9.406691 meter per second squared. And for spectral acceleration 10 is equals to 9.2724446 meter per second squared. So, ayan. So, let's proceed to step 7. Determine the corresponding spectral displacement or SD. Step 7. Determine the corresponding spectral displacement. So, step 7. Determine the corresponding spectral displacement or SD. Ang formula natin for spectral displacement is SD is equals to SA or the spectral acceleration over frequency n squared. So, yung frequency natin, ito yung given frequency, yung na-solve natin kanina, na-determine natin dun sa, after natin ma-determine yung eigenvalue, square root natin yun, ito na yung frequency. So, gagamitin na natin siya ngayon. So, spectral acceleration, na na-solve din kanina, before this spectral displacement, step 6, na-solve natin yung spectral acceleration. So, ito yun sila, yung spectral acceleration natin. Using this frequency and this spectral acceleration and this formula, we can be able to determine the spectral displacement. Ito na yung spectral displacement natin. Spectral displacement for mode 1, we have 1076 or 176.6421 mm or millimeter. For spectral displacement 2 is equals to 37.9965 millimeter. Spectral displacement 3, 14.2927 mm, SD4, 7.7745 mm, SD5, 5.1070 mm, SD6, 3.7599 mm, SD7, 2.8165 mm, SD8 equals to 2.2843 mm, SD9 is equals to 1.9942 mm, and for the SD10 is equals to 1.8634 mm. So, ito na yung magiging spectral displacement natin. So, let's proceed to step 6 or step 8. Modal responses. So, ano yung hahanapin natin dito sa modal responses? Hahanapin natin dito ang modal Storey forces or the FN, represented by the FN. Modal Storey shears, represented by the VN. Modal Storey displacements, represented by the delta N. So, step 8. Compute the modal lateral force or Fi raised to N. So, ang formula niya is ito. Gamma N or the modal participation factor times the mass matrix times the eigen vectors natin. Ginawa nating matrix. Phi matrix natin to. And the spectral acceleration for different modes. Ito yung given, no? Ito yung natin, ito yung modal participation factor natin. Gamma 1, 1.279894, gamma 2, negative 0.436346, and so on. For gamma 10, negative 0.011735. For spectral acceleration naman, we have 5.65255 for SA1. For SA2, we have 10.79, the same until SA5. And SA6, So, SA7 natin, 10.142, SA8, 9.68539, SA9 is 9.40669, and SA10 is equals to 9.27245. And, asan yung natin? Asan yung mass matrix natin? Tsaka yung eigenvectors natin or yung matrix natin for this phi n. So, i-solve muna natin sila, no? Ito, multiply natin tong dalawa. We multiply first the mass matrix and the eigenvectors. Yung matrix natin kanina, yeah, yung matrix natin na ano, phi. So, ito yon. Ito yung magiging result niya for the uh, mode 1 eigenvectors. Ito yon. Mode 2 eigenvector ito, mode 3 eigenvector dito, mode 4 eigenvector ito, mode 5 eigenvector ito, 6, 7, 8, 9, 10. So, minultiply natin to sa ano, no? Sa mass matrix. Mass matrix times the uh, mode 1 eigenvector, then sila, then so on. So, naging matrix na rin siya. So, i-multiply na natin ito ngayon, itong 10 by 10 matrix na ito, dito sa 1 by 1 matrix times ulit sa 1 by 1 matrix, which is the spectral acceleration. So, ayan. Try natin solve ito, no? Itong mode 1. Mode 1 natin. Yung mass times phi1 natin, ito. Then, ito din yung ano natin. Ito yung gamma 1 or the modal participation factor 1. And ito yung acceleration, spectral acceleration 1. Using these values, we can solve our F1 or the lateral force. Yan. Lateral force 1. F1 is equals to, plinag-in na natin dito yung ano, no, yung gamma 1, 1.279894 times the modal mass or the mass matrix times the eigenvector. So, ito yon. Lagay na natin dito. And for the spectral acceleration, 5.65255 to. Magiging result is a 10 by 1 vector, which is our lateral force for 1, mode 1. So, ito yun. 10 ito, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 by 1 vector. So, using this process, using this formula for all the modes, by using this formula and method, we can determine the modal lateral force in all modes and floors. So, ito na yun. For mode 1, first floor, ang lateral force natin is 0.78923. For mode 2, first floor, ang lateral force natin is 1.50146 and so on. Yan. So, for second floor, ito. For third floor, ito na row. For fourth floor, 5th, 6th, 7th, 8th, and 9th, and 10th floor. Then, ito naman yung every mode natin. For mode 1, mode 2, mode 3, and mode 10. So, ito na yung lateral forces natin. So, modal lateral forces, ito. We always take note na lahat ng value na ito is naka-kilonewton, no? It's in kilonewton. Step 9, compute the modal Storey shear force or the VI raised to n. So, ito yung kailangan natin in solving this modal Storey shear force, no? Kailangan natin itong lateral force or modal lateral force na na-compute natin sa step 8. Ito yung formula na gagamitin natin. So, by complying this formula, we can be able to solve for modal Storey shear force, no? Yan. Ito, halimbawa ito. So, using this formula, start tayo dun sa 10th floor, no? Start tayo sa 10th floor. So, since wala tayong 11th floor, 0. 0 plus yung 10th floor natin, 7.878547. Result, our modal Storey shear force for 10th floor is 7.878547 for mode 1. For 9th floor, so, i-add lang natin itong 7.878547 dito sa 9th floor na modal lateral force natin, which is 10.086045. So, ito na yung magiging formula natin o solution natin. Result, our modal Storey shear force for 9th floor is 17.964593. So, this modal Storey shear force at 9th floor plus the modal lateral force in 8th floor, 9.612509, makakompute natin itong modal story shear force for uh, 8th floor. So, using that pattern, we can be able to solve until our mode 1 or for our uh, first floor, I mean. So, halimbawa dito kanina, or dito, na-solve natin yung yung second floor na model story shear force which is 63.078239. I-add lang natin yan doon sa model lateral force ng first floor. So, ito yung solution. The result for the model story shear force for first floor is equals to 63.867471. By using this method, this process, and this formula, these values, given values, we can be able to solve for our model story shear force in first to 10th floor in all modes, no? So if we use this formula in the process presented, we can determine the model story shear force in all modes and floors. So ito na yung model story shear force natin. Ito. So for model story shear force for first mode, ito yung nasolve natin kanina. First floor first mode, first floor second mode, first floor third mode, first floor fourth mode, and so on and so forth. So ito yung last natin, no? 10th floor 10th mode. Ito yun. So ito yung mga modal story shear force natin. And we must take note na lahat ng unit nito are kilonewton. So let's proceed to step 10. Compute the model story displacement or the delta I raised to n, no? Ito yung formula na gagamitin natin. Delta n is equals to the gamma n or our modal participation factor times our Vn or yung eigenvectors natin na na na, inumbine natin lahat, naging matrix. Then itong spectral displacement natin, no? So ito. Yan. Ito yung mga given. Ito yung natin, ito yung gamma 1 natin to gamma 10. Ito yung SD1 to SD10. Gagamitin natin itong lahat, no? Then ito yung phi natin. Eigenvector for mode 1, eigenvector for mode 2, mode 3, mode 4, mode 5, and eigenvector for mode 10. So, parang naging na siya, no? Naging matrix na siya. So, i-multiply natin first ito. Multiply first this matrix to this vector 10 by 1 vector, no? Then, after natin yan makompute, we can solve for the model story displacement by multiplying it here in our spectral displacement. Ito. So, using that formula, in this given, plugging into this formula, we can be able to solve for our modal story displacement. So, try natin doon sa first floor, no? Or sa first mode, no? Ito yung mode 1 natin na phi. Then, ito yung mode 1 natin na gamma 1 or yung modal participation factor natin. Tapos ito din yung mode 1 natin for spectral displacement. I-plug in natin dun sa formula na given kanina. So ito yung result. Ito yung result niya. So delta n is equals to the 1.279894 or yung natin, yung gamma 1 times itong natin, mode 1 natin, no? Ito na phi or eigenvectors times this spectral displacement 176.6421. So ang result yan, it is 10 by 1 vector. Ito yung delta natin. Delta 1 or the displacement, no? Ito. So if we use this formula in the process presented, we can determine the modal story displacement in all modes and floors. So using yung formula kanina plus yung process na pinakita dito, solve na ito yung formula, no? Ito yung process. Masosolve natin yung modal story displacement natin. Ito. Take note na lahat ng unit dito is naka-kilonewton, no? Naka-kilonewton. So ito yung mode 1 natin, modal story displacement, and mode 1 first floor, mode 2 ay mode 1 second floor, mode 1 third floor, and mode 2 first floor, mode 2 second floor, and so on and so forth. So, ayan. Na-solve na natin, no, yung modal story displacement. So, next, doon na tayo sa modal combination. Ano itong modal combination? Ano yung hinahanap dito? Hanapin natin dito yung peak responses. Itong mga ito. Ayan. Solve natin yan mamaya. Peak story forces, peak story shear, and peak story displacement. Using this SRSS or the square root sum of squares na formula. So, ito yung formula niya. Rmax is equal to the square root of summation R1 squared, no? So, ito. Ito yung gagamitin natin where I is equals to the 1 o yeah. Then, ito yung mode natin, no? Mode. Yan. So, yun na nga. Doon na tayo sa peak responses. So, ano yung hinahanap natin dito sa peak responses? Gaya na nasabi ko kanina, hanapin natin ang peak story forces represented by F peak, peak story shear represented by the V peak, and the peak story displacement represented by the delta peak. So, yung mga sa paghahanap ng story shear, forces, displacement, gagamitin natin yung mga value na na-solve natin kanina, no? In solving these responses, peak responses. Step 11, combine modal responses using SRSS-peak story shear. So, kailangan natin dito yung na-solve natin kanina na ito, na shear force, no? Modal story shear force. Kailangan natin ito para ma-solve natin tong peak story shear. Kasi ang formula na gagamitin natin is yung SRSS. So, ito yun. V peak I is equals to the square root of the summation for VI squared. So, itong VI, ito pala, first, so, start tayo dun sa first floor. Ito yung floors niya, no? Yung I represented. Yung floors represented by I, no? So first floor, lahat ito, i-sum up natin, then, i-square root natin, no? So, mahanap natin yung, yung peak story shear. Ito. So, using this formula, and this given, kanina, so, ipa-plug in natin dito yan, nakuha natin yung result. So, ito yun. First floor shear. So, peak story shear is equals to the square root of 63.86747 squared. So, sabi niya kanina dito, squared, no? So, kailangan natin squared. Plus 13.81384 squared. For third mode, 5.092227 squared. Plus fourth mode, 2.71290 squared. Then so on and so forth. So, square root natin yung value niyan. Makukuha natin yung peak story shear na V peak 1 is equals to 65.65878 kilonewton. So, sa second floor naman, no? Second floor, ito. The same process. Second floor, V peak 2. Ito yung given sa second floor, no? Solve natin, i-sum up natin to. Na square natin ito. Then, i-add lahat para makuha natin yung summation niya. Then, square root natin. Then, yung result niya, 64.39596 kilonewton. So, if we use this formula in the process presented, we can determine the SRSS thus peak story shear in all modes and floors, no? Mahanap natin lahat yung yung peak story shear in all floors na lang pala kasi kinumbine na natin yung modes, yung lahat ng value ng ng modal shear force, no? Ay combine na natin lahat yung mode, no? So, yeah. In all modes in all floors, lahat naman ng mode is kinumbine natin. So, SRSS, the peak story shear, ito na yung result, no? Ito yung nakuha natin sa VPIC 1 kanina, 65.65878 kilonewton. For VPIC 2, 64.39596. Ito yun. Ito, no? 65.6878 and 64.39596. So, the rest, VPIC 3 or the peak story shear for third floor, 61.24787 and so on for peak story shear. 10th floor equals 10.45999 kilonewton. So, ito yung peak story shear natin in every floor, no? Yan. So, next step, step 12, combine the modal responses. Okay, step 12, combine modal responses using peak story force. So, ito, F peak I equals to V peak I minus V peak I plus 1. So, ano ibig sabihin nito? So, peak story shear force or peak story force is equals to the peak story shear force kung saang floor yun siya minus the peak story shear force ng kasunod na floor, no? So, ito ang ibig sabihin, ito ang example, no? Ito, tingnan natin, no? Ito yung solving, no? Peak story shear force for first floor is equal to 65.65878. So, ima-minus daw natin ito or babawasan natin ito ng yung kasunod na peak story shear force, kasunod na floor. So, ibig sabihin, maminusan natin siya ng peak story shear force ng second floor which is 64.39596. So, 65.65878 minus 64.39596 is equals to the peak story force of the first floor. So, for the second floor, so ito yung peak story shear force ng second floor, no? So, minus yung kasunod na floor, ito, 61.24787. So, ito yung solution. 64.39596 minus 61.24787 is equals to the peak story force of second floor, which is 3.14809 kilonewton. So, following that process and method, so, masosolve natin yung peak story force from first floor to 10th floor. So, ito na yung value natin. Ito yung solution, ito yung given. So, ito na. Hindi natin i-solve lahat. Hindi natin i-explain lahat, no? Kasi the same process lang yung, the same process. So, tanda natin na naka-kilonewton lahat ito, no? Kilonewton. So, next. Step 13. Solve for SRSS peak story displacements. So, delta peak ang hanapin naman natin dito sa step 13. So, ano yung given? Kailangan natin yung displacement, modal displacements, no? Na nakuha natin kanina sa previous steps. So, for mode 1 first floor, the modal displacement is 17.2593. Mode 2 first floor, 3.96997 and so on and so forth. So, sa dulo, no? Mode 10th floor, negative 0.0219. Yan. So, gagamitin natin ito in solving our peak story displacement, no? Ito pa rin yung SRSS pa rin yung gamit natin na formula. So, ito na. Delta peak I is equals to the square root of summation of all the displacement in each floor, no? In each floor. Then, squared natin yun. Then, square root natin. So, paano yung ginagawa? Ito man yung given. Ito yung given, no? First, solve lang natin yung first and second floor kasi anyway, the same formula and the same process naman ang mangyayari from third floor to 10th floor. So, kung ano yung ginawa natin sa first floor, ganun din ang gagawin natin sa third floor, second floor, hanggang doon sa 10th floor. So, ito yung given, ito yung formula. Delta peak I is equals to the square root of, yun na nga, ito. Following this formula, ito, first floor displacement, delta peak I is equals to the square root of the squares of each floor, each mode na displacement. So, dito sa first floor mode 1, 17.25927 squared plus mode 2 first floor 3.699682, third floor or third mode first floor 1.36847 squared and so on. Then isasum natin yan, then square root natin, ang magiging displacement natin, peak story displacement is equals to 17.73546 millimeter. So, the same process with the second floor, no? Second floor displacement. Delta peak 2 is equals to the square root of the summation of the squares of these second floor displacements, no? Modal displacement. So, ito. So, square root natin yan. The result will be delta peak 2 is equals to 54.15713 millimeter. So, hindi natin isusab lahat, hindi natin papakita lahat, no? Kasi the same process naman, the same formula naman yan. So, kapag ginawa natin ito sa lahat ng floor, ito na. If we use this formula in the process presented, we can determine the SRSS peak story displacements in all modes and floors. So, ito na yung SRSS peak story displacement natin. Ito na yung magiging result na delta peak 1 is equals to 17.73546 mm. Delta peak 2 is equals to 54.15713 mm. Delta peak 3 is equals to 88.6891 mm, and so on. For delta peak 10 is equals to 226.5629 mm. So, ito na yung peak story displacement natin, no? Represented by the delta peak. May sinabi ang NSCP, no, tungkol sa pag-solve ng peak story drift natin. Sa NSCP 2015-208.6.5, sabi niya, story drift shall be computed using the maximum inelastic response displacement or delta M, no? Paano natin solve itong delta M? Ito yung formula. Delta M is equals to 0.7 R delta peak. Ano naman itong R, no? Itong R, ito yung value ng R dito is yung 8.5. Galing ito sa sa reinforced concrete. Reinforced concrete special moment frames, no? Special moment frames. Sa NSCP table ito. Sa NSCP 2015 table 208-11A. So makikita natin doon yung reinforced concrete yung sa letter C. Kasi mayroong A, B, C, D, yun, no? So doon sa letter C, under letter C, or sabihin natin section C. Sabihin natin section C, no? Sa table. So, sabi doon, reinforced concrete special moment frames R is equals to 8.5. So, ito yung gagamitin natin, 8.5, no? So, ito yung ipa-plug in natin dito na value. So, we can now be able to solve for the delta M since meron naman tayong delta peak. Ito yung delta peak natin, no? Delta peak 1. So, delta peak 2, 3, and so on. Delta peak 10. Ito yung mga value niya, no? Maximum inelastic response displacement. So, isusolve na natin ngayon. Ipa-plug in natin tong value dito. Sa, in each floor, no? In each mode. Or in each floor ba to? In each floor, no? In each floor. So, delta M is equals to 0.7 times 8.5. Ito, 8.5. Yung R natin. Times itong delta peak 1 natin, 17.73546. Ito na yon. Pag solve natin to, ang magiging result niyan, so delta M or our maximum inelastic response displacement represented by delta M on first floor is equals to 105.526 mm. So for the second floor, the same formula. So ito yung delta peak natin, 54.15713. So plugging in that value into this formula, so delta M is equals to 0.7 times 8.5 na R times 54.15713. So pag solve natin yan, lagyan natin sa calculator yan. So solve na natin ang delta M or maximum inelastic response displacement for second floor. So ang result, 322.235 mm. So the same formula, the same process. So ito na yung magiging process niya, no? Ito din yung mga delta peak na pina-plug in natin dito. So ito yung formula solution. Then ito na yung magiging sagot natin. Yan. Ito yung result, no? Delta M1 105.526 mm, delta M2 is equal to 322.235 mm, delta M3 is equal to 523 or 527.704 mm, delta M4 is equal to 717.177 and so on. For delta M10 is equals to 1347.712 mm. So ito na yung mga maximum inelastic response displacement natin. At gagamitin natin ito para ma-solve natin itong peak story drift represented by delta peak, no? So sa next step natin yan. Solve for peak story drift. So ito na. Ito yung Pero bago yan, may sinabi na naman yung NSCP, no? Sa NSCP 2015 natin, doon naman tayo nagbabase kasi ng structure natin, no? Building the structures, no? So may sinabi sa 208.6.5.1, no? Sabi niya, calculated story drift using delta M shall not exceed 0.025 times the story height for structures having a fundamental period of less than 0.7 seconds. So, kung yung period natin yung pinaka mataas na period natin doon
sa ano natin, sa RSA natin is less than 0.7 seconds. So, ang magiging story drift natin using the delta M shall not exceed 0.025 times the story exceed uh, times the story height. So, kung meron tayong meron tayong 3 sabi natin 3 meters each floor. So, ito times natin 'yon. Ay gagawin nating millimeter. So, 3,000 times itong 0.025, 0.025. So, 75, no? Yan, 75. So, hindi dapat lalagpas ng 75 mm yung peak story drift natin kapag kapag less than 0.7 second. Pero sabi naman, for structures having a fundamental period of 0.7 seconds or greater, so equal man siya, equal man siya, no? Sa 0.7 or mas mataas sa 0.7 kung meron tayong period na ganun, the calculated story drift shall not exceed 0.020. Nagbaba siya ng 0.005. So, 0.020 times the story height. So, ito na. So, yung period natin, yung sa period 1 natin, since yun yung pinakamataas na period natin, equals to 1.11072 seconds. And this is greater than 0.7 second na sinabi sa NSCP, no? So, kung greater, hanggang, ang provision ng NSCP, the calculated story drift shall not exceed 0.020 times the story height. So, ito na yun. Assuming we have a height of 3 meters in every story. So, yung 3 meters, since mm naman yung yung result ng mga natin kanina, solving natin. So, i-convert natin into mm itong 3 meters. So, 3,000 mm yan, no? 3,000 mm. So, delta max is equals to, ito yung maximum natin na peak story drift natin, no? Equals to 0.020 times 3,000 is equals to 60 millimeter. So, since yun na nga, since greater than 0.7 second yung isang period natin, ibig sabihin, ito yung gagamitin natin, no? Ito, 0.020 times the story height. So, ibig sabihin, dapat yung peak story drift natin, hindi lalampas ng 60 mm. Kasi ito na yung maximum eh. So, ano ibig sabihin nito? Kapag lumampas na sa 60 mm yung peak story drift natin, hindi na natin yun i-consider, kundi gagamitin natin itong maximum na 60 mm. Ito na yung gagamitin natin. Hindi na natin i-consider yung greater than 60 mm. Kasi sabi nga, hanggang dito lang tayo, hanggang S-max lang tayo, hanggang delta max na 60 mm lang tayo, no? So, ayan. So, ito na yung solution, no? Ito yung formula na delta peak I is equals to delta M peak 1 minus delta M peak 1 minus I minus 1. So, ibig sabihin, kung kanina may plus tayo na ganito kanina, ngayon minus na naman. So, start tayo dun sa sa delta M1, no, na 105.526. So, hanapin natin yung peak story drift in first floor, no? First floor. Ito. 105.526 minus I minus 1, since nasa first floor tayo, minus 1, 0. So, wala naman tayong wala tayong ground, no? Wala tayong basement. Wala tayong story 0, no? So, ito na. Sa first floor, minus 0. So, yan. So, ang magiging result, delta peak or peak story drift for first floor is equals to 105.526 mm. So, next, the same process. So, delta M natin, delta M for second floor is 322.23493. So, 322.23493 minus yung previous floor natin, which is 105.526. So, ito, minus. So, our peak story drift for second floor is equal to 216.7089. So, the same yan na process, the same solution, the same method, na makukuha natin yung peak story drift hanggang 9th floor. Ganon din sa 10th floor. Pero, tingnan natin yung sa 10th floor, no? Yung delta M natin, delta M10 is equals to 1347.7124. Imaminusan natin ito nung previous floor natin na 1,313.129. So, ito na yun. Solution. Then, for ang sagot, peak story drift for 10th floor is equals to 34.58343 millimeter. So, ayan. So, uh, tingnan natin yung condition. Tingnan natin yung condition tungkol sa mga ito, no? So, sabi nga na delta max is equals to 60 millimeter lang. So, since itong first floor hanggang 9th floor is lumampas na dun sa maximum na 60 millimeter, hindi na natin ito i-consider. Hindi natin ito gagamitin kasi sabi dun, di ba, for structures having a fundamental period of 0.7 second or greater, the calculated story drift shall not exceed 0.020 times the story height. So, 60 lang. So, dito lang tayo sa 60. So, naka-red yan, no? So, doon tayo sa safe, sa 60 millimeter. Ayan, 60 millimeter lang gagamitin natin as maximum na peak story drift. And yung sa 10th floor naman, hindi naman siya lumampas sa hindi na siya lumampas sa maximum natin na 60 millimeter. So, yun tayong gagamitin natin. Huwag na natin ipaabot ng 60 kasi mas mababa na nga siya sa di ba? Mas mababa na siya sa maximum. So, ito na yung gagamitin natin, no? 34.58343 mm. So, 34.58 mm. So, ito yung gagamitin natin na peak story drift natin. Ayan. So, ayan. Isang mensahe, no? Earthquakes don't kill people, but buildings do. So, anong kailangan? Be a responsible engineer. Ayan. Salamat. Sukran. Okay. That ends my explanation about my assignment. So, I'm Jeric D. Martinez from 4th year BS or Bachelor of Science degree in Civil Engineering, Session A. Thank you.